When converting between rectangular and polar coordinates, it's helpful to memorize a few formulas. So for instance, when you have a polar coordinate r theta and an equivalent rectangular coordinate x, y, we know that r squared equals x squared plus y squared, and that tangent theta is equal to y over x. Furthermore, we know that x is equal to r cosine theta, and that y is equal to r sine theta. Now, it just so happens that when we're converting from rectangular to polar in terms of coordinates, these first two equations are what's going to help us here. Don't get too hung up on these two disclaimers over here, r greater than theta and r greater than 0, excuse me, and theta between 0 and 2 pi. Those are mainly formalities. So if you create your polar coordinate the normal method that I'll show you, these will be satisfied by default. All right, so we can say that r squared equals x squared plus y squared, and we have an x and a y in our point here, so negative square root of 2 has x and y right here, so that means r squared is equal to negative square root of 2 squared plus the square root of 2 squared. And these luckily are just each equal to 2, so this is equal to 2 plus 2, which is just 4. But recall, that's not just r, that's r squared. So r is equal to plus or minus 2. In this method I'm talking about, we wouldn't use a negative because we want r greater than 0. All right. So r is equal to 2. That part's done. Now we need to find our theta. So we know that tangent of theta is equal to y over x, which y here is the square root of 2, and x is negative square root of 2. And I can see that these will cancel out, and so we'll have negative 1 left over. Now, we can use a tangent inverse on that negative 1 in order to find theta, but we want to be a little bit careful there, because we have to know what quadrant our point is in. We have a negative x and a positive y, means it's in the second quadrant. But recall that tangent inverse can only give values in the first and negative first quadrant, right? Or we can call this the fourth quadrant, but shifted back 2 pi. So when I plug this tangent inverse into my calculator, or if I look at the unit circle and I try to find a tangent inverse, a tangent that produces negative 1, I'm going to find this point right here, which would be negative pi over 4. We have to then adjust this angle. And the way we adjust it, since we want to go straight across the unit circle here, is add pi. And we'll end up with 3 pi over 4. My final answer then, since we have an r and a theta, is to write 2, 3 pi over 4.